plus 0.15 z to the negative 2 y of z equals 2 x of z minus 0.8 z inverse x of z. Then you take the inverse z transform. That gives you y of n minus 0.8. So this is going to be y of n minus 1 plus 0.15. This is going to be y of n minus 2. This is going to be 2 times x of n minus 0.8. This is x of n minus 1. And finally writing it as a causal difference equation, just expressing y of n in terms of other quantities, you move all these to the right. So it's a 0.8 y of n minus 1 plus 0.15 y of n minus minus y of n minus 2 plus 2 times x of n minus 0.8 x of n minus 1. And then finally convert it to the anti-causal version. So it means we are looking for y of n in terms of future values of y. So for that we look for the y with the maximum shift, which is this one. We keep that to one side of the equation and move everything else to the other side. You get so keeping this on the left, I get 0.15 y of n minus 2 equals 2xn minus 0.8 x n minus 1 minus yn plus 0.8 yn minus 1. And then finally to get y of n, you replace n with n plus 2 this time, right? So it becomes yn equals, and I'm going to divide everything by 0.15, so you'll have 2 over 0.15 x of n plus 2 minus 0.8 over 0.15 x of n plus 1. So this became an n plus 2, this became an n plus 1, minus y of n plus 2 plus 0.8 y of n plus 1. So that's the anti-causal version. Okay, so and then part C, you're given a MATLAB script. So so because we don't want to give away the answer to the first one, but let's say you were given this, a simpler difference equation here, y of n equals 0.5 y n minus 1 plus xn. And so how would you implement this? So assuming you have an input sequence x of n with length nx, your value of y, it comes off of this equation, right? So it's just a loop over n. So we compute y of 1, y of 2, y of 3 and up till the end, and it's able to look at the previous value and compute the current value. So what's the error in this piece of code?
Is it the initialization on 0?
Where?
Should it be y of n plus 1?
No, I'm starting my loops at 1 this time. I'm not. Huh? This guy? Yeah. I mean, because I specifically said MATLAB. So when you start this loop at 1, this will end up being y of 0. So for the very first time with n equals 1, you end up with the y of 0, which will be an error. So you can't do it like this. So let's look at it. You have for n equals 1 to nx, yn is 0.5 And the problem is at n equals 1, this becomes 0, y of 0, which is invalid in MATLAB. So what's the way out of this?
Plus 1 with y of n, so y of n plus 1. So add
Oh.
like n, go to n plus 1, so y of n plus 1 equals 0.5 y of n plus x of n plus 1.
But then
Just after loop it too. Put an if statement.
yeah.
Zero.
You could either put an if statement, but the if statement would be, it's possible for this case because there is just one, but what if you had y of n minus 1, then a y of n minus 2, then a y of n minus 3? You would have to treat each one of them separately.
Well,
So if statements won't do, but you can,
Change.
I mean if statements are fine, but you can simply start the loop at 2. But again, that's not, it doesn't end there. Yeah, you're gonna miss the first value of y. Y of n equals 0.5 y of n minus 1 plus xn. So when this begins to run, it'll not compute y of 1, and it'll start off at y of 2, and it'll, when it needs y of 1, it'll take it as 0, which is not what we want. So to take care of that, we need to compute y of 1 by hand and put it up there. Like yeah, we have to do it manually and keep the value up there. And again, when you are doing it by hand, how do you deal with the 0? Y of 1 equals 0.5 y0 plus x of 1. So we have x of 1, that's fine, but we don't have the y of 0. Yeah, so we assume our sequences are causal. I mean, anything that we don't know, it's just 0. So this is equal to 0. So y of 1 is simply x of 1 for this equation. So, and x of 1 was what? It was like in, yeah, 1. So y of, so you just predefine y of 1 and you start your loop at 2. Had there been another term like minus 0.4 y of n minus 2, you'd make your loop start at 3 instead, and you pre-compute y of 1 and y of 2 like outside, something like that. And again, this is something we did earlier. Remember, we had a difference equation, and it was on the first exam. You were given a difference equation and I asked you to find y0, find y of n for n equals 0, 1, 2, 3, 4, 5. You remember? This was on the exam, so you know how to handle, those cases like this one where you didn't know y of 0, so you took it as 0. So just do the same thing again and compute those values. But for this problem, you were just asked, what's the problem? So you just say the problem is the index is becoming 0 at n equals 1. On the exam, whatever we talked about today, you get it. So something related to that. So make sure you understand this. Then this one, it's very similar to the DTFT problems of a very similar kind. We asked to refresh those kind of problems. It was, you were given something like this: x, say h of minus k, x of n minus k, and you were asked to relate the DTFTs. So we said that this doesn't look like the regular convolution. It looks like a convolution of h of negative n with x of n. So in the frequency domain, it would be the DTFT of h of negative n, which was h e to the negative j omega, times the DTFT of x of n. Right? And like on the exam, we actually had h of negative k x conjugate of n minus k. So this again is not your regular convolution. It's a convolution between h of negative n and x conjugate n. Right? So you look up the DTFTs of these two and multiply them together. It would be h e to the negative j omega x conjugate e to the negative j omega, right? So a similar property, like the convolution property, it's the same for the Z transform. So here in this problem where y of n was, so we already saw this thing here. It's a convolution of h of negative n with x of n. So what's the Z transform of h of negative n? I mean, you should remember this by now. It's
Z minus 1.
yeah. If you don't, then it'll be bad on the exam. It'll be h of z inverse x of z. So this is the straight x of n going to x of z. This gets changed into this. So y of z is just this. And again, somebody could switch this thing around. You could have h of minus k x of k minus n. So that implies h of negative n convolved with a x of negative n. Both of them have a time reversal. So it means both of them will have a z inverse in there. Something like that. But for this problem, it's just this. Then this is straight from the homework, and we've done plenty of, I think we already did this in the class, this exact same problem. It's just using partial fractions to find the inverse Z transform. Right? So the very first thing that we do is we write it as x of z over z, 1 over z plus 2 times z minus 3, and then we work on splitting this into partial fractions. So we try to write this as a over z plus 2 plus b over z minus 3 and then to calculate a and b, you remember whatever is in the denominator, you take it out of the original expression, and whatever is left is 1 over z minus 3. There you substitute whatever the pole here is. The pole here is z equals negative 2. So you substitute z equals negative 2 here, and you end up with negative 1 over 5. For this guy, for b, you take this denominator term out of the original expression, you're left with 1 over z plus 2, and here the pole is z equals 3. So you plug in z equals 3 in here, you get 1 over 5. So your xz over z is negative 1 over 5, 1 over z plus 2, plus 1 over 5, 1 over z minus 3. And now you can move this z back up there so that the inverse Z transform is easier, because the inverse Z transform that we remember had this form.